Hi everyone. Okay, so today we're here to talk about motion of a particle. So there's a few things we need to review before we get going. So remember, let's say that the name of our position function is s, or f of t, or s of t. Okay, then displacement, which is the change in s, that's just the final position minus the starting position, or f of t plus delta t, the change in time, minus the original f of t. Average velocity is the displacement over the travel time. It's delta s over delta t. The instantaneous velocity is the limit as the change in t gets small, as the interval gets small, of our average velocity. So it's the limit as delta t heads to 0 of f of t plus delta t minus f of t over delta t. By the way, that's the same as f of t plus h minus f of t all over h. Does that look more like your definition of derivative formula now? Okay, that is your definition of derivative. So it's s prime of t or f prime of t, depending on which number we're using, and that is our new function v of t. It's also important to remember that speed is the absolute value of velocity. Velocity gives you not only how fast the particle is moving, but the direction. Positive means it's going either to the right or it's moving up, it's moving in the positive direction. Negative means it's moving left or it's moving down. Velocity is the rate of change of your position function. It's the derivative. And acceleration is the rate of change or the derivative of your velocity. So, but in symbols, if position is s of t, then velocity is s prime of t, or ds dt. And a of t is the derivative of velocity, but remember, velocity is the derivative of position, so it's the second derivative. Acceleration is the second derivative of position, or the derivative twice of position with respect to time twice. Okay, so we're going to look at an old problem. We're looking at a dynamite blast propels a heavy rock straight up with a launch velocity of 160 feet per second. That's about 109 miles per hour. It reaches a height of s of t equals 160t minus 16t squared feet after t seconds. Now, we are going to find first, how high does the rock go? Next, how long is it in the air? And then there's another question coming up, but we're going to deal with these two first, and we're going to find them graphically as well as algebraically. So we can use our calculator to find how high the rock goes. If we put our function into f1 of x, so f1 of x is 160, you have to change the t to x, minus 16x squared, and we find the maximum. Okay, so we're going to go to our calculator and we're going to find the maximum. Then, if we want to know how long it's in the air, remember, this object is going up and it's coming back down. So when it comes back down and it hits the air, it's no longer in the air, its height is 0. You're looking for the x-intercept. So we're going to take a minute, we're going to do both of these graphically first, then we're going to come back and look at how to do them algebraically. Okay, so we're going to open a graph window, and in f1 of x, we're putting 160x minus 16x squared, and notice we're not going to see much of anything, so we need to adjust this window. We want Windows Zoom, Windows Settings. We don't need negative time, so we can make that 0. Take a guess how much time you think. It looks like I can see it there almost at 10, so let's just go a little bit. Let's just go to 20. What the heck? And we'll leave the scale on auto. I don't need negative heights. I usually like to use a -1 just so that I can find any points of intersection. It makes it a little easier. My Y max, take a random guess how high you think it's going to go. Let's just randomly guess 500. I don't know. Let's see. Oh, not bad. Okay. Perfect. Perfect. Okay, so there we go. So now for part 1, how high does the graph go? We go to menu, we analyze graph, we find the maximum, we go to the lower bound, upper bound, we do the left and the right. There it is. So our maximum is the 0.5400. What is the answer? The answer is the y value is the height. So 400, and the unit is feet. So our maximum height is 400 feet. Next up, how long is it in the air? So how long is it in the air? We're looking for when does it come back down to the ground. So we need the x-intercept. So I'm going to tab up here and I'm going to graph y equals 0. And then I'm going to find the point of intersection. You can do that either by going analyze graph and finding your intersections, or you can do geometry, points and lines, intersection points, click on both. I need to escape out of that. Just going to slide these so you can read these labels. We've got so many things up here already. Now remember, the 0, 0, that's when the rock was initially thrown up out of the air, so that this time, 10 seconds, is when the graph lands back in the air. So it's been in the air for 10 seconds. Okay, so now algebraically, how high does the rock go? We're looking for a maximum. When the rock goes up, it's going to come up, it's going to reach its maximum, which when you're at that maximum, the velocity, because it's the derivative, that velocity is going to have to be 0. So we are going to take our velocity function and set it equal to 0. So we need to find a velocity function. If s of t is 160t minus 16t squared, velocity is the derivative of that, which would be 160 minus 2 times 16 is 32, t to the first. So we're going to have 160 minus 32t equals 0. 160 is 32t, and if you divide both sides by 32, we get t is 5. Now we're not looking for the time. The time is when our particle is at its maximum or at its biggest height, but we need to know the height. So we have to take that time 5 and plug it into the position function. So it's 160 times 5 minus 16 times 5 squared. So that, if you do your little bit of arithmetic and your handy-dandy calculator there, hopefully we get the same answer we got graphically as 400 feet. All right, now algebraically, how long is it in the air? When it's no longer in the air, its height is going to be 0. So we're going to take that position function, 160t minus 16t squared, and set it equal to 0. We have a GCF of 16t, which will leave us with 10 minus t. So t can be 0 or t can be 10. Now t equals 0 is when it started, which means the answer we want is 10 seconds. Nice. Okay, there is another part to this problem. Now we want to know what is the velocity and the speed of the rock when it is 256 feet above the ground on the way up. This 256 is the height. That's the position. So we want s of t to be equal to 256 feet. So s of t is 160t minus 16t squared equals 256. So to solve this, I'm going to put everything on the right-hand side, and I'm going to have 16t squared minus 160t plus 256. My GCF is 16, which will leave me with t squared minus 10t plus 16. And then I can factor, and that's going to factor, let's see, what multiplies to 16 and adds to negative 10. That's a negative 2 and a negative 8. So t is either 2 or 8. Okay, now remember, that's when it's happening. We want the velocity and the speed. So remember, our velocity function, which we found earlier, is 160 minus 32t. So on the way up, okay, v of 2 would be 160 minus 32 times 2, which is going to give us 96 feet per second. Now the speed is also 96 feet per second. However, we also have to look, and this time, right, it went up, so you'd think thing went up and it down, and here's that 256. So on its way up, it was at height 2, and on its way down, it was at time 8. Okay, so on its way down, we do the velocity at 8, so it's 160 minus 32 times 8. Do a little bit of mental arithmetic here. We're going to get negative 96 feet per second, which means that our speed is still 96 feet per second, because remember, speed is always positive. But that negative is telling us that the rock is on its way down, and the positive velocity is what's telling us the rock is on its way up. Now, let's see if we can do this graphically. So graphically, remember, we're going to need to have our function in F1, which I believe we already do. Then in F2, we need to set that equal to 256, and we need to find the intersection. Okay, then we will use our calculator to go from there, and we'll talk about what happens next. Okay, go grab your calculator. Okay, so here we're looking for when the velocity and speed of the rock when it is 256 feet above the ground. So one of the advantages to how I found the x-intercept is if I tab up and I change that 0 to a 256 and hit enter, I now have my answers to this question. Okay, it's happening, both of these have a height of 256. It's happening at time 2 and at time 8. Now, how can we find the velocity if I have not found the velocity function algebraically? I have my position function here. So I'm going to add a calculator page, Control Doc, calculator page, and I'm going to use my template key for my derivative. So the derivative with respect to x of, and my position function was in F1 of x. Then remember, we have to get out of our derivative, control equals for the such that, and we want this derivative, now I know it's usually t, but we're using x, equals 2. So it's time 2, we press enter, there's 96 feet per second. Now we can arrow up and make this a little easier, backspace over the 2 and change it to 8, and now we have negative 96 is our velocity. So at time 2, our velocity is 96 feet per second, our speed is 96 feet per second. At time 8, our velocity is negative 96 feet per second, which means it's going down, and our speed is positive 96 feet per second. Okay, new problem. The accompanying figure shows the velocity v equals f of t of a particle moving on a coordinate line. When does the particle move forward? So the first question is, when does the particle move forward? If the particle is moving forward, the velocity has to be positive. So if we're moving forward and we're looking at a graph of the velocity, we want to know when this graph is positive. When's it above the x-axis? Well, that would be between 0 and 1, and then again from 5 all the way till 7. Notice it's not inclusive. Then, when is it moving backward? If it's moving backward, the velocity would have to be negative. So that would be underneath the x-axis. So when we're underneath the x-axis, that's from 1 all the way till 5. And it's the only time it's below the x-axis. Next, when does the particle slow down? Now, for a particle to slow down, that's when the velocity and acceleration have different signs. So that if the velocity is positive, it's above the x-axis, but the acceleration is negative, which means the slope is negative, so that would be here from 0 to 1. Okay, and And then when the velocity is negative, when it's below the x-axis, if the velocity is negative, the acceleration would have to be positive, which means it would have to be going up. That would be here from 3 to 5. And now velocity is positive again. So if velocity is positive, we would need acceleration to be negative, which means that the velocity graph is going down. So that's happening here from 6 to 7. Next question. When is the particle's acceleration positive? So now we're looking at the slope. So we need that's got positive slope, which means our graph is increasing. So when it has positive slope, when does it have positive slope? Everywhere from 3 all the way till 6. Next, when is the acceleration negative? That's when you're going to have negative slope, or when the graph is decreasing. So that graph is decreasing from 0 all the way to 2, and then it's decreasing again from 6 until 7. When is it 0? That's when it's horizontal. When the velocity is horizontal, because there's going to have a 0 slope. So 0, when do we have a 0 slope? That's right here between 7 and 9. Right? Is that 7 and 9? Yes. So that is from 7 less than t less than equal 9. Okay, remember the derivative acceleration doesn't exist at 7 because there's a sharp corner, but it does exist at 9. Now, when does the particle move at its greatest speed? Now, that's talking about speed, which is magnitude of velocity. You would have to look at the absolute value graph, or really just when is the graph farthest from the x-axis. And that actually happens twice. It happens at t equals 0 and everywhere on the interval from 2 to 3. So here we're down here at -2, and here we're up here at +2. That's when we're the furthest from the x-axis. That's when the speed is 2. And finally, one more part to this question. When does the particle stand still for more than an instant? If it's standing still, that means that the velocity is 0. But they don't want to know just at this instant and just at that instant. They're not looking for that. They're looking for when is it standing still for several moments in time. Now it can't happen at 7 because it's not differentiable there, and all the way to the 9. Okay? And there's one more area which we almost missed down here between 2 and 3. So 2 less than t less than 3 is also when the particle is standing still. There we go. So we did one graphically. Let's take a look analytically. All right, a particle moves along the x-axis so that at time t, its position is given by x of t. What is the velocity of the particle at t equals 0? Before I can find the velocity at 0, we need to know velocity function. And remember, velocity is the derivative of the position function. So the derivative of t cubed is 3t squared minus the derivative of 6t squared is 12t plus the derivative of 9t is 9 plus the derivative of 11 is 0, so I don't need it. Now I can find the derivative at 0, so it's 3 times 0 minus 12 times 0 plus 9. My derivative at 0 is simply 9. Now, during what time intervals is the particle moving to the left? If the particle's moving to the left, that means that the velocity is less than 0. Okay, so we know we've already found our velocity function is 3t squared minus 12t plus 9. We're going to factor this. We'll take out a common 3 and set it equal to 0. we're going to factor this. What multiplies to 3 and adds to -4? That's a -1 and a -3. So this is t equals 1 and t equals 3. Now we're going to set up a number line. And we need 1 and we need 3. We say, okay, my velocity function, if I pick a number between 0 and 1, like a half, and I plug it into this factored form, I'm going to get positive, negative, negative. Negative times positive is positive. Pick a number between 1 and 3, like 2. 2 minus 1 is positive. 2 minus 3 is negative. Negative times positive is negative. Then a number bigger than 3, such as 10. 10 minus 1 is positive. 10 minus 3 is positive. Positive times the positive 3 is also positive, which means that our position function here, x of t, our particle is moving to the right, then to the left, then to the right. So our question was, when is the particle moving to the left? So therefore, the particle is moving left for, and we have it right here, right? For 1 less than t less than 3, since velocity is negative. And you can say is negative or v of t is less than 0. Either one of those is okay. There's one more part to this problem. What is the total distance traveled by the particle from t equals 0 to t equals 2? Now, when you have these total distance problems, you need a t, you need the position, and then you need the distance that it has traveled. Now, you need to know the start time. Well, we're starting at t equals 0. You need to know the stop time, which was at 2. But you also need any times that the velocity is 0, because that's when your particle could change directions. Now in part B, we found that the particle changes direction at 1 and 3. But 3 is not in our domain from 0 to 2. So we only need the 1. Now we have our position function, and we're going to do some substitution. And if we find x of 0, we're going to get 11. If we find x of 1, it's going to be 1 minus 6 plus 9 plus 11. We're going to get 15. And if we find x of 2, that's going to be 8 minus 6 times 4 plus 18 plus 11. We're going to come up with 13. Now, distance must be positive. Remember, if you lay down a ruler, you're only going to get to measure something, you're only going to get positive numbers. So make sure when you're subtracting, you're taking the absolute value of the difference. How far is it between 11 and 15? That's 4. How far is it from 15 to 13? That's 2. It doesn't matter which direction you're traveling in. What's the difference between the two? Give me a positive difference, or put absolute value around it if you're not sure which one's bigger. And if you traveled 4 units, then 2 units, that's a total of 6 units traveled. All right, guys, we did a lot on motion, and we're going to spend some more time in class working on motion problems. But here we are for today. I hope you all have a wonderful day. Bye, guys.